Welcome to Hocking College, Lab 11-2, week of day 1. This was May the 4th, so May the 4th be with you. Um, Today we're going to talk about gravimetric methods, gravimetry, and there we go. So gravimetry is basically anything where mass is your analytical signal. So essentially anytime you are weighing something or part of something as the output of your analysis, that's gravimetric method. So technically, weighing yourself on your bathroom scale is gravimetry. Um, okay, so we can divide gravimetry into a lot of broad categories, one of which is precipitation gravimetry. If you think back to the very old analytical method for measuring the amount of nickel in an ore sample that was an example in the first week or two, it had a lot of uh, react this react the ore with something, pour off the liquid, weigh what's left over, react that liquid with something, let it settle, weigh the particulates. That would be an example of precipitation gravimetry. Um, they tend not to be used as often anymore for the most part because they can be fairly time consuming. If you remember, that was a 18-day method, I think, something like that. Um, Essentially, you add something to your sample to desolubilize the analyte or an analyte, and you filter that out and weigh it. Um, to do this, you have to know all the chemical reactions involved, how much of this reacts with that, and what it makes in the end, because whatever precipitates out is going to include something besides your analyte, whatever it reacted with. Um, if you think about something like sodium chloride, um, if we react it with something so the chloride settles out, you've got you know some other chloride salts that settled out, um, but you could use that to back calculate how much sodium chloride you had in your solution. But you have to know all those reactions and the ratios involved. Uh, One of the things I really liked about this particular section of the book is it gave some nice pictures of correct methods for actually pouring out and uh, for pouring something into through a filter. Um, so to begin with, if you've got one of the big round filter papers, this picture down here shows the correct method for folding it. You fold it into quarters, separate it a bit, rip off a corner, turn it into a cone, and stick it in your funnel. There are also styles of filters where you can where the funnel is a two-part thing that clamps together. You put your filter over the bottom part, which usually has a coarser screen on it to support the filter. Then you put the top portion, which kind of just looks like a piece of tube on top, clamp it together, and then you don't have to worry about folding anything. But the other thing I liked was this nice diagram of how to actually pour something through a filter cleanly and neatly. I hadn't seen this before. It's fairly nice. So you have your filter touching the wall of your beaker, so you will pour down the side of the beaker instead of splashing. Um, so you're reducing splashing there. The glass stirring rod across the top through the spout. You're going to have to get used to how to hold the beaker and keep the glass stirring rod in place. Um, as you do that, there's some technique involved, but that's going to help prevent drips and also splashing. If you're pouring carefully, the fluid will roll down the glass stirring rod and into the side of the funnel. Um, your funnel is going to be held by um, probably a ring on a ring stand, so you don't have to worry about holding the funnel while you're pouring. So there's some techniques you can draw from that diagram there. Um, Another broad category is volatilization gravimetry. Essentially, you're heating it up and seeing what happens to the mass as it's heated up. Uh, Thermogravimetric analysis is one of the broadest categories of this, subcategories of this I can think of. It's very, very common in biomass related work. Excuse me. Excuse me. So as I said, it's very, very common in biomass related work and a few other fields like that. Essentially, you're going to you've got a machine like this, a TGA, a thermogravimetric analyzer. It is essentially a microbalance where instead of the pan you rest things on, it's set up with a hook that hangs down below the balance, and you put your pan. Um, Pan attaches to that hook. It's a little basket type thing, and then that all drops down into this furnace here, where it's heated up, and you have gas that flows across it. You can either have a nitrogen or argon, or something something fairly inert, and you can see its behavior without oxygen in biomass stuff. That's usually to see how things how pyrolysis works with this. So you're doing things like finding out how much biochar you can produce. You can collect the off gases and see what you would get in terms of syngas production and things like that. Um, or you can do it in an oxygen atmosphere, so air, oxygen, and you can actually combust the sample in this and see how the mass changes with combustion. Um, in the end, you get something called a thermogram, which is a nice diagram of weight versus temperature. You can see your initial weight, and then we're driving water off probably. As it started a little bit above 100, we're going to be driving off the water. Then the weight's going to be constant for a while. Then something is either being driven off or reacted, and the weight's going to be stable for a while. Then as it gets hotter, something else happens, and the weight changes again. So you kind of see these reaction steps as things heat up. Some other types of volatilization gravimetry are finding the ash content. Again, this is fairly common in biomass or plant-based materials. We used to do this at the pulp mill with the wood chips. Um, you heat the sample in a muffle furnace, usually at 900 to 1,000 degrees C. At the pulp mill, we had a couple of different methods that were both part of the standard method. I think one was at 950 and one was at 450. So you heat it inside a crucible in the furnace, and then weigh the ash that remains, and you get the ash content at whatever temperature it was at. Um, a lot of times, especially with plant-based materials, you need to know the water content. So you'll dry the sample in a drying oven. Frequently, this is temperature just slightly above boiling for a fairly long time. A gentle temperature for a longer time. Uh, Depending on what the purpose is, you might have a procedure that's a higher temperature for a shorter amount of time as well. But for the incoming chips to the plant, they would do I forget what temperature they used. It was a higher temperature, and I want to say 30 minutes or so. Maybe it was less, so that they could determine the actual weight of plant material that was coming in minus the water, so they could know how much it was worth. Um, in the lab at the mill, we did things at 105 degrees. Usually, popped it in the oven overnight and dealt with the samples the next day. Um, in the control rooms where they were doing tests that where something had to be dry, they had essentially a skillet type thing that they dried things in. It was a little bit hotter, but and you couldn't leave the sample on for too long. But you put your sample down and dried it and did what you needed to do. Another type of volatilization gravimetry that the book describes is an organic analysis. You burn the sample, uh, direct the smoke to go through a series of absorption tubes. Uh, each tube needs to be pre-weighed, and it selectively absorbs something out of the smoke, and then you weigh the change to determine the content of CO2 or you know, water or whatever that's been absorbed, and you can determine how much carbon was in the sample. That's it's going to go to CO2. How much hydrogen there was. That's what's going to produce your H2O. Things like that. You've also got particulate gravimetry. In essence, this is filtering. So this goes from large scale filtering, which is generally called sieving. You've got on the lab scale, you've got mesh screens. I've seen them from 4 inches in diameter to probably about 8. They tend to be stacking. You put the coarser ones on top and the finer ones on bottom. Put your sample in on the top. They get shaken. There are nice machines that do the shaking for you, and the particulate matter goes through until it hits a screen that it collects on. Then you weigh the amount collected at each screen, and you get the size distribution of your sample. Um, Another example of this would be filtering a water sample to see what the suspended solids content is, things like that. Uh, you can do extraction as a particulate gravimetry method. Add something the analyte is soluble in, evaporate the solvent, and weigh the particulate that's left over. Um, be an example of how to do that. Absorption, like the tubes described for the organic analysis. Okay, let's shift gears for a minute and talk about safety. Um, I thought I'd sit outside to do this, and I think it's honestly gotten colder as I've sat out here. But I'm enjoying the fresh air, so I guess it's worth it. Um, so let's talk about basic lab hygiene and PPE. PPE is, of course, personal protective equipment. Hygiene, often we think hygiene as cleanliness, wearing deodorant, shaving, whatever. It's also another definition of it is the science of establishing and maintaining health. So when we talk about lab hygiene, we talk about things that are done to maintain a safe environment and keep the laboratory workers healthy. So that can range from keeping things clean, making sure there's nothing to trip over, making sure you don't have puddles of something you might accidentally stick your hand in. Um, Goes from that to wearing the correct clothing to things like that. Um, so we'll talk a bit about clothing here. The idea behind clothing and personal protective equipment is to keep your skin and eyes safe, mostly. Um, it's you want some sort of barrier between you and spills. So closed-toed shoes are a must. You do not wear sandals, open-toed sandals, or flip-flops or anything like that in the lab. Um, it's just not safe. Both from chemical spills being right on your toes and to breaking glassware. Um, if you work in a lab, you will break glassware at some point. We all do. Um, you will break less the more you work in one, but you will still break some on occasion. It will happen. You will drop something. Uh, Closed-toed shoes also would protect you somewhat from the falling glass and glass shards. Um, if you if you drop a beaker on your shoe, it's not likely to, or knock it off and glass bounces a little bit. It's not likely to land on your toe and cut you if you're wearing a closed-toed shoe. It's unlikely but possible that it could land, in between your toes and cut your toes if you were wearing something open-toed. Uh, the same logic. You want long pants. You want something covering your legs. You don't want shorts. No shorts. They're not allowed in the lab. No short skirts. They're also not allowed in the lab. I'm a little less sure about whether long skirts and dresses are allowed. I haven't checked, but in general, you want something that will cover your lower legs and keep you uh, from spilling something that contacts your skin or splattering. Um, there will be splatter. Any time you work in a lab, uh, people who work in a lab tend to have the set of clothes with tiny pinholes from things that have splattered a little bit. Uh, it's going to happen. Um, so you're not going to want to wear your best, nicest clothes for lab work. Um, but you do want something to be that barrier to keep your skin from getting those tiny pinpricks of something on them. Um, Again, by the same logic, a lab coat is a great idea. It gives you essentially a disposable layer that not only protects you but kind of protects that your clothing a little bit. They tend to be a little longer, tend to be long sleeved, so you can you know maybe wear something that's more comfortable for the weather as well. Um, Safety glasses or a face shield, um, you know, obviously to protect your eyes. One of the things that's different between safety glasses and regular glasses is the safety glasses have a bit of a side shield built in to protect you from getting splashed, you know, from the side. Um, and then gloves. The type of glove varies with the chemical needs. Not every glove material will block every chemical, and that's the compatible glove types will be listed in the MSDS. Again, if you think back to the beginning of the course, we talked a little bit about material safety data sheets that manufacturers are required to provide that provide the basic safety and disposal information, and a lot of information related to the something's playing in the leaves down there. It's distracting. Sorry. A lot of information about the chemical and and how to handle it safely. Okay, that is what I had for today. So